Okay, we're still on section 1-1, so we'll try to finish this up right now. Let's put it on the pen thing. All right, we're good to go. Let's do another one like we did yesterday with that order of operations. So here it is. Write this down. So it's 8 plus 6. That's in parentheses. So we have a parentheses, and then divided by 7 times 3 minus 6. Okay, and times 3 minus 6. Okay. And I think yesterday I said they say simplify, but I'm looking at the book and they say evaluate each expression. Basically means the same thing. Okay, so it says evaluate, or it could say simplify. I've seen a lot of books that say simplify the expression or something like that. Okay, just figure out what the answer is to this. Just do the work and figure it out. So do you remember your order of operations? Remember that? I always remember it like this. Please, excuse. Is anybody taught that way? Yeah. My dear Aunt Sally. My dear Aunt Sally. All right, it's just a way to remember the order, okay? Just a little saying. What do they call that? A mnemonic device. You ever hear that word? Okay, so P is for what? Not please, but parentheses. Then talk to me. And then, all right, good. You're awake this early in the morning? Very good. All right, so what do we do first? If you see any parentheses, you always do the stuff in the parentheses, even if it's addition or subtraction. Even though that's at the end of our list, addition and subtraction, if it's in parentheses, you do that stuff first. Does that make sense? Because I've had people tell me, Mr. Hammer, you said don't do the addition first. Okay, but they didn't hear the parentheses part. You do what's in the parentheses first. So let's do that. So what do you get right there? It's 14, okay? And let's just write it all out, might as well. I mean, some of you guys can just fly through this in your head, but we'll show all the steps, make sure we know what's going on. All right, now, what do we do? Exponents. Well, there's no exponents here, so I can skip that. Now look at this. Multiplication and division, they're kind of like the same. You kind of do those basically in the same step, okay? If you see a multiplication or division, you do those first. Now, what I would do, if you see a division and multiplication, I would go left to right. So I would go 14 divided by 7 first, okay? And then, even though division is after multiplication right here in that, our little list, I would go in order. I would go 14 divided by 7, which is 2. And then let's write the rest of the stuff down. Make sure that minus is bigger than that dot. Sometimes they kind of look the same. All right, so make sure you know exactly. All right, so we did the division first. Now we do the multiplication. 2 times 3, that's 6. And then minus 6, that's easy. And that equals what? 0. All right, notice how I worked. I worked down like this, didn't I? Okay, that's usually, normally in algebra, that's the best way to do that. Write your problem out first and then show all your work all the way down to your answer. Now look. This is how I wrote out the problem when I did it for you. So I want you to do the same exact thing when you do this stuff on your work. Okay, even on the worksheets. You may not have like a ton of room, but there's actually quite a bit of room on this worksheet over here off to the side. So you could, like what I would do, there's really not a whole lot of room under each problem on this worksheet. It's a little bit squished together, but you got a lot of room to the outside. So what I would do is I would rewrite the problem. Okay, over there on the right-hand side where you got some space. Rewrite the problem, and then show all your steps. I'm going to be picky about showing your work. If there's, I might have mentioned this yesterday, but for the homework, I don't grade your homeworks if the problems are right or if they're wrong. Okay, I only grade on completion. So all you got to do is just try to do the work. I mean, you could get every single problem wrong in your homework and still get a 5 out of 5 on the homework. Okay. I wish you would get every problem right and not everyone wrong. Okay, we're going to try to make sure that doesn't happen. But you could get every problem wrong and still get a full credit for the homework because I only grade on completion. But what I'm looking for is this stuff. All this stuff. This is what I'm looking for. Not just looking for the answer. Don't just put number 1, 0. Number 2, 5. Number 3, -2. All right, if that's all I see, all right, you may not get any credit for your homework. All right, I may take off 2, 3, 4, depends on how I feel about it, okay, how much work you showed. All right, and if all you do is this, I'll probably say show work. And I might even get really mad and put an exclamation point. That'll scare you. Oh, no, I don't know. I don't know if I've ever been that mad, but boy, if I put 2, you better watch out, okay? So anyway, but I'll put, and if I underline it all, you're in big trouble then. All right, so if I say show work, I'll probably put like a -2 or a -3. And a -2 on one homework assignment is a big deal. So what would your percentage be on your homework if you had a -2?
60.
It'd be a 60, wouldn't it? Because -2, that's 3 out of 5, which is 60%. All right, just not for not showing your work. All right, look. I almost said I don't care if you get the right answer or not. I do care if you get the right answer, but I'm not marking off, okay, if you get a wrong answer. Follow me on that? Okay, so don't just say, oh man, he doesn't care if you get the right answer. I'm just going to write anything down. Well, I want to see your steps. That's what I'm more concerned about than even the final answer. I'm more concerned with this stuff. Now, on a quiz or a test, obviously I'm grading on if the problem is right or if it's wrong. But on homeworks, it's basically an effort grade. All right, enough of that. Let's do another one of these. So this is a little bit more involved. Almost say complicated. I wouldn't say that. It's just more involved. Plus -5. Watch this. Big old division. And then 2 times -8. And then minus 5 times 3. Alright, so here we go. What's that big fraction thing? I said it just a second ago. What does that mean in math?
Divide.
It means divide. Okay, so what we're going to do is this. When you see a big old fraction bar like this, you're not necessarily going to go in that order of operation thing. Okay, what you're going to do is you're going to work the top first. Okay, so do the top. Okay, figure out an answer for the top, and then do the bottom. Figure out the answer for the bottom, and then go ahead and see if you can divide it. All right. Sometimes it might just come out as a fraction. You don't have to do anything. If it comes out as a fraction, leave it as a fraction. Don't stick it into a calculator and get some decimal number. If it comes out as a fraction, leave it as a fraction. Everybody hear me on that one? Okay. So let's do this. Now I did say work up and down, but I got some room over here to the right. I'll work to the right and then I'll go down. Okay. So what are we going to do here? Now a lot of people would see this. You see two negatives next to each other. And when you're in pre-algebra, algebra 1, what'd you learn about a negative times a negative? It's a positive, right? But you got to be careful about this, especially when you have exponents, okay? What do we do first before you do the multiplication? We do exponents, don't we? Okay, we got to do exponents. Now, there are parentheses here, but there's nothing you can really do inside the parentheses, is there? I mean, there's a -3 there. It's just -3. I can't add or subtract. You can't do anything. So, really, I'm just doing exponents first. So this is what we do. We do the exponents first. All right, so that thing right there, you got to figure that out. So let's figure that out. We talked about that yesterday. It's a -3. The whole entire -3 is being squared. So it's -3 times -3, which is what? It's +9, okay? So it's a +9. But what's floating out front of it? A negative. So you got to put a negative right there. So it becomes a -9. You see that? A lot of people, believe me, I've seen this many, many, many times. A lot of people see, oh, two negatives next to each other. That's kind of like everybody's favorite, isn't it? Remember when you first did pre-algebra, you saw two negatives next to each other, and you're like, oh yeah, that's always positive. And it made it really easy. But on this one, you can't think that way because you've got an exponent right here. So you do the exponent first, you get a +9, but then this negative out in front makes it a -9. We good with that? Okay, that always is a little bit of a problem for a lot of students. Now look at this. It's a plus -5. Now there's no exponents here. Well, what's the same thing as plus a negative? You could just write it easily as just a minus. Exactly right. So we could just say -5. That's a little easier, isn't it? You could put plus -5 if you wanted to. That's fine. But just kind of like to get rid of all the parentheses. It kind of gets in the way, doesn't it? All right, so I'll work that in the next step. Let's do the bottom now. All right, or you could just keep going if you wanted to. Let's just do that. You want to do that? Because I said work the top first and the bottom. So let's do that. Even though I am going across, that's okay. What's -5 or 9 minus 5? -14. Now look, I know some of you might just pull out a calculator for that, but we shouldn't, at this point, when you're a junior and senior in high school, you shouldn't be doing that. Okay, you should be looking at this and saying it's -14. I used to teach this back when I taught pre-algebra and algebra 1 years ago. I would say this. When you have a minus, you always turn it to a positive. So I always said add the opposite. Pretty simple little thing. Just add the opposite. So when you see a minus sign, you add, which means you turn that to a plus. Add the opposite. What's the opposite of +5? -5. And now you just go by the rules of addition. All right? So in pre-algebra, algebra 1, you learn those rules of addition. If you're adding two things that are the same sign, you just add them up and you keep the sign. Do you remember doing that stuff back in algebra 1? Yep. So anyway, there you go. Mrs. Swam has a little cuter way of saying it. Who's had Mrs. Swam? What does she say? She say?
Add a line, change the sign.
Very good. She add a line, change the sign. All right. I just say add the opposite. Mine's not as cute and fancy, but it works for me. All right. So add a line, change the sign is what she says, and it seems like students here that have had her remember that. All right. Anyway, that's -14. Let's do the bottom. What do we got here? We do the multiplication first, don't we? There is a subtraction here, but we do multiplication first in the order of operations. So we do this first. 2 times negative 8. When you multiply two numbers with different signs, your answer is always what? It's always negative. Okay, so this is going to be a negative 16. And then watch, I'm just going to stick the minus right there. It's a minus. And then I'm looking at this. It just depends on how you look at it. I look at this as a minus and this as a positive 5 and a positive 3. All right, so what is that? Okay, yeah, it's a 15. So you got the minus because of this, and you got the 15 because of 5 times 3. All right, and now we can work that one out. So negative 16 minus 15 is the same style of problem as it is up here. I say add the opposite. So negative 16 plus negative 15, you add the numbers, you keep the sign. What is that, 31? Is that right? So it's negative 31. Does this reduce? Does 14 over 31 reduce? No, do not change it into a decimal, okay? When it comes out as a fraction, leave it as a fraction, unless in the instructions I tell you to write it as a decimal. I say for the most part, just keep it as a fraction. Now, I wouldn't leave it like this.
I get rid of the negative sign.
That's what I would do too, because what's a negative divided by a negative?
Positive.
Right, same thing as a negative times, did we do a negative times a negative? We didn't. But anyway, if you had a negative times a negative, same thing, so that's positive. But I'm going to write it nice and neat, without all the signs around it, just 14 over 31. And that's how you would write the answer to that. Okay? No decimals. Just keep it nice and pretty just like that. Did I do that right? C, D, D. Oh, you know why? Yeah, we did that right. Because in the book, they wrote cubed. I didn't see that. I put a square instead of cube. I'm like, what am I doing? I thought I did that right. I did it right, didn't I? Okay, good. When I see a different answer, I'm like, oh, okay, I must have done something wrong. All right, enough of that. Let's, they give one more example like that, but this is pretty much the same deal. Let's skip to another kind of problem.